Welcome to the debate. Today, we're diving into what is, well, arguably, one of the most vexing definitional challenges in modern technology. What exactly is artificial general intelligence? AGI. As the capabilities of large models keep expanding, almost exponentially it feels like, the AGI definition has often felt like a constantly moving target.
And that ambiguity, that slipperiness, is precisely why the source material we're looking at today is so interesting, I think. It really tries to cut through that fog by proposing a very academic and crucially quantifiable framework. This framework defines AGI not in some vague sense, but specifically as matching the cognitive versatility and proficiency of a well-educated human adult. And it measures this rigorously through a structured assessment.
Exactly. And it operationalizes this using the Cattell-Horn-Carroll theory, or CHC theory, of human cognition, which is, a really deep psychometric model. The framework then gives us this quantifiable metric, an AGI score. And it shows that right now, even state-of-the-art models like, say, GPT-5, are currently sitting around, 57% of that human benchmark.
Right, a score, which gives us concrete diagnostic data. And that alone is progress, I'd say.
Absolutely. But the core question that's driving our debate today is more structural. Is grounding the definition and the evaluation of artificial general intelligence, primarily in this CHC theory of human psychometrics, really the most methodologically sound way to diagnose AI progress? Now, I believe this empirically validated structure is a necessary tool. It gives us the rigor we need for systematic diagnosis.
And I'm coming at it from a slightly different angle. While I certainly respect the rigor, I'm going to argue that relying, perhaps too rigidly, on a model derived exclusively from human cognitive architecture, well, it introduces significant interpretive flaws, especially when we try to map the emergent and often quite jagged profiles and maybe the technological compensatory mechanisms we're seeing in these artificial systems.
Okay, I see why you might raise concerns there about, let's call it anthropomorphism, but let me offer a different perspective on why the CHC framework is so essential. Look, to move past these vague notions of generality, we have to ground the definition in the only existing proven model of general intelligence we actually have. Us, humans. Right? The framework uses the CHC model because it is by far the most robust and empirically validated model of intelligence out there, refined over, a century of intensive factor analysis, that statistical synthesis of how diverse cognitive abilities tend to cluster together in people. And this process, this factor analysis, it allows for objective, quantitative measurement that goes way beyond just simple test scores. It actually dissects general intelligence into 10 distinct broad abilities, things like fluid reasoning, memory, visual processing, and then hundreds of narrow abilities underneath those. So this rigorous approach, it replaces those nebulous, hard-to-test concepts with concrete, measurable metrics. And when you aggregate those, you get that precise AGI score. It moves us out of sort of philosophy and firmly into engineering diagnostics.
That's a powerful case for the framework's internal consistency. I grant you that. Though I would frame the result quite differently. The data that this very framework produces immediately suggests that while the CHC map might be robust for us, for humans, it may actually be an incomplete or maybe even a misleading blueprint when you apply it to non-biological intelligence. The cognitive profile it reveals is what the source calls jagged, and we see this so clearly in the assessment results, right? Current systems show, high proficiency in certain CHC domains. For instance, they get high marks in mathematical ability, that's M, in the framework, and reading and writing, RW. Yet at the same time, they show these profound, almost total failures in what you'd think would be foundational cognitive machinery.
You mean specifically the long-term memory storage score, the MS score?
Precisely. The long-term memory storage, MS score, is pegged at 0% for both GPT-4 and the newer GPT-5. Now this extreme unevenness, high scores in output domains like reading and writing, alongside a literal 0% in a core acquisition domain like memory storage, it demonstrates, I think, that trying to model AGI based purely on the hierarchical structure of human architecture forces an assessment that highlights structural deficiencies. Deficiencies that might just be overcome technologically in ways that simply diverge from our biological constraints. I mean, why should a synthetic mind have to follow the exact same architectural path as a biological one?
That is a critical point about architecture, and it leads us right into the structural components of the CHC framework itself, specifically its taxonomic map and maybe more contentiously, the methodology of equal weighting. See, the value of this framework, in my view, is that detailed hierarchical map. It ensures we aren't just measuring some high-level performance, but the underlying mechanisms. To really qualify as general, an AI system needs to show versatility and breadth across the entire spectrum. The decomposition of broad abilities into these narrow abilities, like, for example, showing that auditory processing, A, requires discrete capabilities like phonetic coding and speech recognition, that forces a holistic, a multimodal assessment. It stops an AI from just, gaming the score by being exceptional in only 2 or 3 high utility areas.
And I do understand that push for breadth, but let's scrutinize that equal weighting for a moment. The framework assigns exactly 10% to each broad ability. Now, while this attempts to prioritize versatility, the framework's own authors acknowledge quite openly that this equal weighting scheme is a significant limitation. It risks obscuring critical failures in core, bottleneck capabilities. Let's take your example again, that long-term memory storage MS score of 0%. Imagine a future AI system that somehow scores 90% overall on this scale. Yet because of the equal weighting, that 0% score in MS means the system is still, fundamentally, functionally impaired by a kind of amnesia, right? High scores in areas like general knowledge, K, or fluid reasoning, R, become practically worthless if the system simply cannot reliably acquire, retain, and integrate new information from recent interactions into a stable long-term state.
Being defined as general intelligence, whether human or otherwise, capable of matching a well-educated adult. The CHC structure, by giving MS that 10% weight, is acknowledging its importance, not diminishing it.
I'd argue it is diminishing its criticality. Look, if memory retention is an absolute prerequisite for cumulative learning, which seems like a fundamental feature of generality, then maybe a 0 score there should, arguably, nullify any claim to AGI entirely, regardless of what the other 9 scores are. The equal weighting just fails to capture the inherent interdependence, the hierarchical importance of foundational components like stable memory within a cohesive integrated AI engine. And this suggests that a strictly additive human-derived psychometric model might not be the best way to map a synthetic architecture.
I'm not quite convinced that calling a complete lack of stable memory merely a bottleneck is, intellectually honest in this context. Long-term memory storage, as defined here, involves associative, meaningful, and verbatim memory. These are the absolute pillars of cumulative learning. The framework's strength is precisely in identifying these non-negotiable deficiencies with rigor, which actually brings us directly to our second point, how we interpret these so-called capability contortions.
Okay, and I agree the framework is rigorous in identifying these issues. It clearly points out how existing systems display these capability contortions, where basically inherent strengths are leveraged, sometimes aggressively, to compensate for deep underlying weaknesses. And we see this vividly in the engineering solutions being deployed. For instance, think about the enormous context windows in large language models, often tens, even hundreds of thousands of tokens. That's essentially brute forcing working memory capacity to try and compensate for the architectural lack of stable long-term memory storage. Yeah, they can reference recent conversational history within that window, but once that context scrolls away, the information is just gone.
And what about the retrieval tools, RAG?
Ah yes, RAG. That's an even better example probably. The integration of external search tools, Retrieval Augmented Generation, or RAG. These systems are explicitly designed to mitigate the imprecision in long-term memory retrieval, which is, what we often call hallucination.
These external tools go fetch facts from databases to try and ground the responses. Look, these aren't just signs of deficiency. They are sophisticated, adaptive engineering solutions that allow these systems to perform tasks that will look like they require long-term statefulness or high precision, even when the core cognitive architecture is fundamentally lacking those things.
Okay, calling them adaptive engineering solutions is technically correct from an engineering standpoint. But the CHC framework's designation of contortion is, I think, far more accurate in the specific context of AGI diagnosis. It correctly highlights that these technological workarounds, however clever, are insufficient substitutes for integrated organic cognitive capabilities. RAG, fundamentally, is a dependency. It's a dependency on an external database. It's really just a sophisticated search function. It's not integrated memory. It cannot substitute for the holistic, integrated memory required for genuine contextual learning, or for maintaining personal identity adherence, or for adaptive long-term contextual understanding, all of which are necessary features measured in the MS and MR sections if we're aiming for true human-level AGI. The framework's analysis is strong precisely because it distinguishes between systems that might genuinely possess general intelligence versus systems that merely simulate aspects of it through costly, often inefficient external dependencies.
But this whole debate about what counts as integrated versus external capability, well, it leads us right to the fundamental issue of scope, which is our point 3. The definition, as you've said, focuses laser-like on the core cognitive capabilities deemed necessary for a well-educated adult's mind. You pointed out how things like theory of mind and cognitive empathy are sort of tested through narrow abilities within on-the-spot reasoning, R, and general knowledge, K. The focus is strictly, well, cerebral.
And that measured limitation of scope is absolutely vital for analytical precision. We are trying to define general intelligence against the best available empirical model we have. If we start including too many variables, physical skills, specialized economic output, the definition becomes unwieldy, basically useless. We are seeking to define AGI in terms of mental capabilities, not specialized physical labor or, its current economic value.
Yet the framework explicitly excludes entire faculties, like, for example, the kinesthetic and spatial abilities proposed by other theories, like Gardner's multiple intelligences. It excludes them precisely because CHC focuses primarily on abilities derived from factor analysis of standardized cognitive tests. Now, this exclusion becomes immediately problematic because the source material itself defines related concepts, such as replacement AI, which explicitly includes physical tasks as part of its criteria. So by relying solely on CHC, the framework, while maybe providing an excellent measure of the, let's say, cognitive desktop of a well-educated human, it risks setting criteria that are just too narrowly defined to measure broader, perhaps technologically advanced forms of synthetic general intelligence. I mean, if an AI achieves generality through, say, embodied learning and interaction, which seems necessary for the next stage of robotics, will this CHC-based framework even recognize it as general intelligence?
That's a fair concern, definitely, about future technological paths. But we have to remember the premise here: systematic measurement against the cognitive architecture that currently defines general intelligence, and the only example we have. If, down the line, an AI achieves a fundamentally different kind of generality, well, then we'll need a new metric, won't we? This framework is specifically focused on systematically evaluating human-level AGI and the capabilities it measures: complex reasoning, memory retrieval, common sense knowledge. These are the bedrock of what it means to operate competently in the world, regardless of physical form. The mental faculties being tested are the intellectual capacity required to adapt and learn. They are, you could say, the intellectual preconditions for building or coding or managing a physical system. The framework focuses on the engine of versatility itself.
And look, I concede that the framework is invaluable. It forces a certain intellectual humility, and it certainly replaces a lot of hand-waving with quantified diagnostics. That AGI score is extremely useful. However, we absolutely must continuously question whether human-derived models, despite their deep empirical history, might inadvertently impose architectural constraints that are simply unnecessary for synthetic minds.
We need to be wary that our reliance on CHC doesn't somehow prevent us from recognizing or maybe even building novel forms of synthetic general intelligence that just don't happen to conform to our particular biological structure.
And I'll just reaffirm that until AI systems demonstrably resolve these fundamental critical deficiencies identified by this very framework, specifically that persistent near 0% score in long-term memory storage, MSS, then the claim of achieving AGI remains fundamentally premature. It remains unverified by rigorous systematic testing. The CHC approach provides the only methodology currently available to us to pinpoint these deep, critical defects in the AI engine, ensuring that evidence and rigorous academic reasoning, not speculation or hype, guide our understanding of the genuine path toward AGI.
Artificial General Intelligence, AGI. We hear that term all the time, right? It's supposed to be the ultimate goal of AI research. But what if we've been chasing something we can't even properly define? Well, a new landmark paper from some of the absolute heaviest hitters in AI, we're talking Yoshua Bengio, Erik Schmidt, is about to change all that. They're putting a concrete number on AGI for the very first time. So let's just ask it straight up. What is artificial general intelligence? This is the question that's been haunting researchers for decades. And look, without a clear answer, the whole field is kind of lost in the fog. How do you know if you're making real progress or just spinning your wheels? And hey, don't just take my word for it. The paper's authors themselves call the term AGI frustratingly nebulous, acting as a constantly moving goalpost. And you've seen this happen, right? An AI beats a Go master and we go, okay, cool, but that's not real intelligence. Then it generates photorealistic images and we just move the goalpost again. This ambiguity, this is the core of the AGI definition problem. Without a proper measuring stick, we're basically like sailors trying to navigate without a compass, totally lost in a sea of hype and speculation. But more importantly, it makes it really hard to see the actual measurable gap between the specialized AI we have today and the versatile intelligence we see in humans. So the paper proposes a solution that's as simple as it is powerful. They're basically saying, let's stop the endless philosophical debates and just start measuring AI against the only verified example of general intelligence we have, which is us. The whole idea is to stop making up random benchmarks and start using the same solid methods we've developed to understand our own minds. And this leads them to a really clear, testable definition. They define AGI as an AI that can match or exceed the cognitive versatility and proficiency of a well-educated adult. The two keywords there are versatility and proficiency. Versatility is the breadth of skills, and proficiency is the depth and reliability. It's not about being a superhuman calculator. It's about having a mind that's a solid all-rounder. Now, this isn't just some definition they made up. The researchers built their entire framework on a super solid scientific foundation. It's called the Cattell-Horn-Carroll theory, or CHC for short. To put it simply, it's the gold standard, the most respected and scientifically validated model of human intelligence we have, backed by more than a century of research. Okay, so how does a century-old theory about human brains help us with modern AI? Well, the researchers used it to take that big, fuzzy concept of general intelligence and break it down into 10 specific core cognitive abilities, things we can actually test and score. And here they are, the whole shebang. It covers everything from learned skills like math and reading to the raw machinery of thought, like working memory, how you process sound, and just pure speed. Now, here is a really critical detail. Each of these 10 areas is weighted equally, at 10% of the final score. And that's a huge deal because it mathematically forces the AI to be good across the board, not just have these crazy superhuman spikes in one or two areas. To really see why this framework is so eye-opening, check this out. AI is already becoming superhuman in very specific areas. A future model like GPT-5 could probably solve a crazy hard geometry problem like this one, a problem that would make most of us just, throw in the towel. It's seriously impressive. But then you turn around and ask that same system to do something incredibly simple for a human. Like, hey, remember my favorite author from our chat yesterday? And it fails, completely. This massive difference between superhuman skill and, frankly, subhuman failure, that's the whole key. And that brings us to the core revelation of this paper. Current AI doesn't have a nice, smooth learning curve. Instead, it has what the authors call a jagged cognitive profile. Think of it like a skyline, with huge skyscrapers right next to empty lots. And this is a groundbreaking insight, because it just demolishes the idea that bigger is always better in AI. It suggests that just throwing more data and compute at the problem won't fix these deep, fundamental valleys of incompetence. So after putting today's top model, GPT-4, through this whole battery of cognitive tests, what was its final AGI score? The answer? Well, it might be a little lower than you think. It's just 27%. That number is a stark, quantifiable measure of just how far we really have to go. But that total score doesn't even tell the whole story. This breakdown, this is way more revealing. Just look at the scores for GPT-4. You see multiple absolute zeros. A zero in on-the-spot reasoning, zeros in visual and auditory processing, and most critically, a big fat zero in long-term memory storage. Now, look at the projection for GPT-5. Sure, the total score more than doubles to 57%, but that crucial memory storage component, still a flat zero. And this chart illustrates that jagged progress perfectly. You see this massive jump in areas like math and reasoning between GPT-4 and what they project for GPT-5, but in long-term memory storage, which you could argue is the most fundamental ability for learning from experience, there is zero progress, nothing. The bar is flat at the bottom for both models.
So the most important point is this. The single biggest bottleneck holding AI back from AGI is what the paper just calls amnesia. Without the ability to actually form and store new long-term memories, the AI has to relearn the world from scratch every single time you talk to it.
So what does this jagged profile mean for the future of AI development? Well, it fundamentally changes how we should be thinking about the path to AGI. It's not about just making models bigger anymore. It's about a focused, targeted effort to fix these fundamental, broken parts of cognition. The paper introduces this really fascinating concept they call capability contortions. It's where an AI uses one of its strengths to fake an ability it doesn't actually have. A perfect example is using a massive context window, which is a form of working memory, to pretend it has long-term memory. It works for a little while, but it's an incredibly inefficient and fragile workaround. It's not a real solution to its amnesia. The authors offer this really powerful analogy. They say to think of intelligence as a high-performance engine. You can have the most powerful pistons and the best fuel injectionist system in the world, but if your transmission is broken or a wheel is missing, that car is not going anywhere. The overall horsepower is always limited by the weakest component. And right now, the AI engine has several parts that are completely broken or just missing. That memory storage system, it gets a zero. It's just not there. On-the-spot reasoning has huge gaps, and visual reasoning is still in its infancy. It doesn't matter how much we boost the other components, these broken parts are going to cripple the whole system. You see, this new framework doesn't just give us a score, it gives us a roadmap. It points a giant spotlight directly at the broken parts of the engine. With critical components, especially memory, still completely non-existent, the path to AGI isn't some big mystery anymore. The real question is, which research team is going to be the one to finally build that missing piece?